Yo, gang, what you saying? What you saying? How's life, Mike? Yo, Kira, what's up? Yo, Blocks. Hey, yo, Blocks was in my year 13 stream as well. That's crazy. This is the hardest one for me. What? Kira, it's not looking good, Mike. Yo, Zabeth. What are you saying? Static is back as well. Come on. Quick, sweet Sam. Hey, yo, allow your dog, Kira. You can just memorize, innit? You can do it after. When do you guys start school? Yo, Alex. I'm assuming everything's all sorted out for you guys now. All of them, Kira. Uma, what's my favorite song? I don't know if I have a favorite song, but probably like my top most listened to songs, probably like Come and Get Your Love by Redbone. It's next week. It's come round quick. Blocks. It's next week. Right. It's all quick, mate. Yo, monkey. Okay, because my teacher's swapping exam boards, but she has not told me which one. Oh yeah, don't worry about that, Kira. A-level normal maths is all the same, bar like one or two things, but they're very, very small. What's the matter with my hair? Wait, what do you mean? What's the matter with my hair, monkey? What? Svanik. It has similarities, it has commonalities, but like they're not the same. But they're founded by the same things. Come on, Isaias. Locked in for the next year. Let's go. Is further maths different in other examples? Yes, Isaias. So if you're talking about further maths, then it is different between Edexcel, AQA, and OCR. Nice blocks. Yo, Asher, what are you saying, dude? Binomial expansion got me a U in my further maths GCSE mock. Ayo, Svanik, one topic wouldn't be sufficient in you getting a U, mate. That doesn't make any sense. What's up, Lily? So, guys, we're going to learn about the binomial distribution today. The binomial distribution is the largest topic in year 12 statistics. So last lesson I showed you guys some mechanics. Now I'm going to show you guys some statistics, and this is the biggest topic in statistics year 12. Now, its principles are the same as the binomial expansion. Do you guys remember we have n choose r, 10 choose 3, 10 choose 5, all of this stuff. The binomial distribution has the same underlying principle, but today I'm going to show you where this n choose business even comes from, and it's to do with combinatorics. So let's look at three objects, three unique colors. What's the total amount of arrangements we can make with them? So you guys can do it with me. We have POY. Can you guys give me the other arrangement beginning with P? Then you'll tell me the rest of them. It says POY. Alex, you are right. Let's list them first. PYO. Okay, can you guys tell me the other options that begin with O this time? Yo, Taj. OYP. And OPY, nice. And then finally, well, Alex, nice blocks. Come on. Got year 5s in the house. Alright, now we got Yop. Do you guys remember that advert? Give me Yop. Give me Yop, me mama. Yop, me mama. Do you remember that? Or are you guys too young? You guys don't know about Yop. So there's 6 options. Okay, there's 6 options. Now there's another way of representing all of this. The yogurt drink, yeah. I don't know if it exists anymore, but hey, yo, that advert was too good. I don't think adverts are built the same way. Like, they've definitely tamed them down. So goated. Hey, yo, Jawa here, you're violating. So, we first have to think of this in terms of, like, do you remember when you guys did tree diagrams? Say you had these three objects in a bag. You're talking about the number of options you have at each round of choosing. So at the beginning, how many options do you have? So we're gonna, in reality, we're never gonna list them. So I'm gonna show you how we numerically can find it. So we don't have, okay, there you go, Michael, good. You have 3 options. So guys, at the beginning, when you're doing a first take, you have 3 options. AO blocks. Nah, get out of here, this guy. No, once you've chosen a random option, say P, you're then left with 2 options, right? Then once you've chosen that one, you're left with 1 option. I think here it's clear to see how these 3 numbers make 6, right? You multiply, just like we multiply across branches, isn't it? So 6, yeah, the 6 options is just 3 times 2 times 1. And in maths, we know, or we should know, this is known as 3 factorial. Yeah, so going forward, we're going to be using factorials. So what this means, all this means is that 3 factorial is the number of ways of arranging 3 unique objects. Okay, very important that we understand this. If you're in GCSE, my GCSE class, I might have introduced to you this kind of 3 factorial. We didn't need it, but it was just like general knowledge. So if it was 4 unique objects, what would it be? And what would the final number of arrangements be in this case? So if we have 4 unique objects, 4 factorial mark, and Michael's given us 24. Lydia agrees. So you guys are right. 4 factorial is 4 times 3 times 2 times 1, which is 24. This number is more important than what the combinations are. There's no way we're listing 24 options, yeah? So we're never going to have to list the different options. We're only ever going to write down how many combinations there are. And I'll show you how it links to the binomial distribution very soon. So n factorial is n times n minus 1 times n minus 2. So you take that number and you multiply it by the integers that precede it down to 1. Yeah? And it refers to the number of combinations of arranging n unique objects. They have to be unique for n factorial. They have to be different objects. However, yo Tazib, the binomial distribution observes something slightly different. And we'll look at what the binomial distribution properly measures later. But it only deals with 2 outcomes. So basically 2 colors. So for example here, let's take a look at a set of purple and orange circles only. What would the total number of arrangements be here? Now, here, yeah, we have loads of different options. We have the most obvious option, which is poo. Then, I don't know, you could switch the P and the O, popo. Then you can swap the P and the O and get poop. Like, there's loads of different options, right? But we don't want to have to list them out. So there must be a better way of doing these things. Oppo. Bro said that's blue. Now that's purple, man. Hey, yo, nah, that's crazy. So the question is, without having to list all of these, how do we find out how many unique arrangements there are? The first thing you do is you first assume that they're unique. So guys, if all of those colors were unique, how many different ways would there be to arrange them? So if they were unique, what would it be? Yo, Gabriel. So if they were unique, how many different combinations? Good, 4 factorial. So guys, keep it in terms of factorials for now. So like Zainab's done. So keeping your answer in terms of factorials is 24, but we're going to say 4 factorial. Okay. This is if unique. All right. Now, obviously 4 factorial, guys, is a multiplication. Now, what we want to do is we want to remove the combinations that are not unique. For example, if I swap these two around, it doesn't make a difference, right? So what we need to do is we need to write down the number of ways of arranging those two non-unique objects. And Zainab, you're very close. So I need factorials here. Basically, you're just saying, look, if they were unique, how many different ways are there of swapping them around? What would you guys say? So you're saying, look, there's 2 objects. How many different ways are there of arranging them? And then you know that they are not unique. Exactly, Zainab, 2 factorial. Yeah, Mark, good. There's 2 factorial. So guys, because there's 2 circles here, there is 2 factorial different ways of arranging them. And it's that combination that is not unique. We need to remove it. Yeah, we need to remove it from that 4 factorial. Yeah. So if 4 factorial is multiplication, what do we need to do to that number and 2 factorial to remove combinations? What do you need to do there? Any thoughts? Remember, 4 factorial is a multiplication, 4, 3, 2, 1. So what would we, good Michael, we have to divide. Yeah, Zainab, you wrote that before, and that is true, Kira, good. So we have to divide, that's how we remove combinations. We're dividing by the non-unique combinations, which for purple would be 2 factorial. So let's write this down. There are 2 factorial ways of arranging the purple circles. Yeah? And those are non-unique. These are non-unique, which is why we have to remove it. And then for the orange, it's going to be the exact same. So that also needs to go in the denominator. Yeah? That's orange. Alright, monkey pickle pants. Maybe you can call them blue, innit, if you want. So we then have to simplify that. The talk Wi-Fi is not looking good. So here, guys, let's simplify it. 4, 3, 2, 1 divided by 2 factorial is 2 times 1 multiplied by 2 times 1. What are we left with? We do blocks. Always ahead of the game, my friend. Ahead of the game. Talk Wi-Fi is peak. You're saying 6. Yeah, because the 2 and the 1 cancel. This 2 cancels with the 4 to make 2. 2 times 3, 6. So I guess I got half of them here. There's just 3 more that we could have found. But these are the best ones, I guess. Alright, so let's practice that again. What would the total number of arrangements be in this case? So, remember there's a fraction, right? Can you guys tell me what's going to go in the numerator in terms of factorials? What goes in the numerator? Umar's going with 6 factorial. Everyone's going with 6 factorial. Nice. So guys, there's 6 objects here. We're assuming that they are unique. But we then have to remove the non-unique combinations. What are we going to put here and here? Lily, Zainab, good. 4 factorial. There is 4 factorial purples and 2 factorial orange. Simple. Very simple. 6 factorial, 6, 5, 4, 3, 2, 1. 4 factorial is 4, 3, 2, 1. And then 2 times 1. Can you guys simplify that? You don't need a calculator here. You can see that 4 factorial does end up cancelling. It helps you simplify things much faster. Matt, he's gone with 15. Zainab, to be honest, I just felt like putting dot. You could put times if you want. It's because I get cussed out on Instagram for not using times. Some people like to use dot. But yeah, 5, 4, 3, 2, 1. 4, 3, 2, 1. Then that 2 cancels the 6 3 times. 3 times 5, 15. Nice. 15 different ways of arranging these objects. The main thing, guys, is as long as these two numbers add up to give you this number, you're all good. So let's generalize this. If we have two types of objects only, n total, r of one type, what's the total number of arrangements we could make? So what goes on the numerator? Dot is used a lot in computer science. Ah, I see. Alex, Matty. Good, guys. So yeah, n in total, we first obviously assume they're unique. N factorial, good. N factorial. What do you think goes here and here then? See if you guys can... Yo. Lydia, good. R factorial will be on one of them because it's R of one type. Now, if we have R of one type, what would we have to put in the other one? Zayas, nice. Lily, good. So, n minus r. So, n, take away r, gives you the rest. 6, take away 4, is 2. Yeah? 4, take away 2, is 2. N, take away r, is n minus r. Do you guys recognize that formula? I did the binomial distribution with you guys, right? This is n choose r. This is the formula for n choose r, which we can do in the calculator. For example, if you guys get your calculators out, we did the binomial together, right? I introduced you guys to the binomial distribution. Where's my thing? Oh, I didn't. Oh, okay, fine. So, can you guys look at your... Oh, it might be near 13. Oh, okay, I'm not sure. Can you guys see your divide button? Can you see there's a n choose r there? There's an n choose r. Can you see it says NCR? So what you need to do is... I'm tweaking that, get out of it. So, look at the one above. There's 6 objects. And I'm going to do Shift and the divide button to access C. Then I'm just going to say there's 4 of one type. 15. Could have done it the other way around. I could have said there's 2 of the other type. There's 2 oranges. 15. Yeah, so whether I put 4 or 2 doesn't make a difference, right? Because we're doing n minus r. Yeah, this is symmetrical. So this is how the calculator can do it for us. And that's how we're going to do it going forward. We're basically just going to let the calculator do everything for us. So in year 12, I will teach you guys the binomial distribution. Yeah. I will show you, the binomial expansion. Yeah. Never knew that's what the C button was for. Now you know, dude. Now you do. So I'm going to show you in what situation we use the n choose r function. So we use the binomial distribution to model situations which is something that we don't need, Taj. So we use the binomial distribution to model situations which have a fixed number of trials, meaning you're going to conduct an experiment and you're going to observe something a finite number of times. Now they can only be a success or failure per trial, and I'm going to give you an example to help you understand what I mean by that. Now, the probability of success and failure has to be fixed. Yeah? Now, we've already just established what this formula is. It's a number of ways of choosing R items from a set of N items without regard for the order. Yeah? So, check this out. This will help you guys see what we're actually trying to do here. So, say I throw a coin 10 times. What is the probability of obtaining 3 heads? Okay. Now, when you look at this situation, what do I mean by there is a fixed number of trials here? What do you guys think I mean by there is a fixed number of trials in this situation? So don't think about probabilities here. We don't need to, if I say I'm throwing a coin 10 times, what is the probability of obtaining 3 heads? What do I mean by there is a fixed number of trials? Good. We're only throwing the coin 10 times. Yeah, exactly. So I couldn't, for example, say I'm just going to keep throwing this coin. I'm just going to keep throwing this coin until whatever. Yeah, I'm literally saying I'm only throwing it 10 times. Fixed number of trials. Let's write this down. So there's a fixed number of trials. Ten throws. Okay. What do I mean by there's success and failure? What does that mean? Nice, Lydia. Heads or tails? I'm interested in observing heads, right? Obtaining 3 heads. So either you get a head or you don't. Yeah, there can only be 2 results, exactly. So success and failure. So you get heads or tails. Yeah, tails being the failure. The probability of success and failure has to be fixed. What do I mean by that? (50-50) in terms of probability. But what would it be in terms of a probability? Assuming it's a non-biased coin, what would it be in this case? So we wouldn't say 50-50, right? What would we actually say? Half, 0.5. Kira, yeah. Okay. Now there's actually only one more thing we technically have to say when we're talking about a binomial distribution, and the word begins with I. So each flip has to be I of each other. Each trial is I of each other. It's a very common word we use in probability. Not indifferent, independent, Zainab. Yes, nice. So independent, it's just a very common, so for this to work, they have to be independent, indicating that the probability remains fixed. Yeah, so we're just going to say each trial is independent of one another. Okay. So you're going to flip a coin. It's either heads or tails. Flip the coin. It's either heads or tails. If it's heads, it's a success. If it's tails, it's a failure. Yeah, nice, freaky. Part B. Find the number of ways of obtaining 3 heads out of 10 throws. Now, what do you guys think that would look like in terms of factorial? So now imagine you have 10 coins. I want 3 of them to be heads. What would be the number of ways of arranging 3 heads out of 10? You can tell me in terms of factorials, because we've kind of built our whole process on these factorials. I see you, Lydia. 10 factorial over 3 factorial, 7 factorial. What do you guys think about that? Matty agrees, Umar agrees, everyone agrees, nice. So guys, if they were unique, there would be 10 factorial different ways of arranging things, right? But we have 3 of the same heads, so it's going to be 3 factorial. And then if you have 3 heads, then 7 of them would be tails. Okay, just exactly like what we were doing here. It's basically this. Yeah, it's just imagine heads, 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 and these are like your 2 tails. Yeah, so same thing. Now, how would you write this? Because we're not going to simplify it ourselves like we were doing before. What would that be in terms of n choose whatever? What would that be in terms of n choose? What would that look like? Zainab 10 choose 7. Other way around, Taj, but yes. And it'll be 10 instead of 7. Okay, so remember guys, n is your number of trials, which would be 10. Choose r, so 3. You can actually do 7 as well. So guys, 10 choose 3 or 10 choose 7 would be the exact same value. The only reason we don't do this one in general is because we're observing the successes, which is 3 heads. So that's why we do 10 choose 3. Yeah? Okay. When you guys type in 10 choose 3, what do you get? Lily got 120. Can you guys confirm? Is it 120? Zainab got the same. Okay, cool. So all that means, guys, is if you had 10 coins, 1, 2, 3 heads, 1, 2, 3, 4, 5, 6, 7 tails. There is actually, yeah, because Taj, you're not typing in the right thing. It says 10 choose 3, not 3 choose 7. So 3 heads, 7 tails. There is 120 different ways of getting 3 heads and 7 tails. So you can mix it all up. We're not going to write that down. Yeah? So without writing that all down, we just know the number of combinations. Now, the next thing we want to do is to find the probability of obtaining 3 heads out of 10. Okay? Now, what the binomial distribution helps us not do is when you are at GCSE, you would have to do a tree diagram. Now, your tree diagram would look something like this. Guys, there's no way you're doing this, right? I can't even fit it in. Heads, tails, heads, tails, heads, tails, etc. You would have to go along all of those branches and keep picking 3 heads and 7 tails, yeah? There's just no way you're doing that, right? At GCSE, we never went past 3 branches, 3 sets of branches. Even at A-level, we would never go past 3 sets of branches. And this is what the binomial distribution helps us address. Now, the way we do this is very simple. We basically say, what would be the probability of achieving the most basic combination of 3 heads and 7 tails? So if you're going to go head, 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 then all those 7 tails, how would you calculate that probability of 3 heads and 7 tails? So you're going to do 3 heads in a row, then you're going to do 7 tails in a row. What would that look like? 1, 2, 3, 4, 6, 7, like that. What would that probability look like if you were going to compute it, assuming it's fair? Gonna have to use some powers here now. So you're gonna go heads, heads, heads. So Asha, that'll be the tails bit. So you're right, tails would be a half multiplied by itself 7 times, right? Now, you guys are right, that would be power 10, but I want to keep it separate just to make a point here. So Asha said a half to the power of 7. What would the heads then be? So don't combine them just yet, because in general it's going to be different. So Freaky, there you go. It would be power, but yes, it would be a half cubed. Yeah, for the heads. Good job, what's up? Now, exactly, so for the heads, guys, it would be a half cubed because there's 3 heads. And for the tails would be a half to the power of 7. Okay? But that is only one combination, right? You're basically then saying how many of the same branches are there? Remind me, guys, how many of the same branches are there? It might look something like this, and all these tails and 3 heads. How many of the same branches do we have? There's 120. Exactly. We worked out that there is 120 of these branches. So what do you do to this value to then total all of those branches together to say this is the probability of achieving 3 heads and 7 tails? Yes, Taj, exactly. Nice. You just multiply it by 120. And there you go. This is going to tell us the probability of getting 3 heads out of 10 trials if you flip a fair coin. When you guys type that in the calculator, what does it give you? So 120 times a half cubed 0.5 power 7. Get that? Get this number, 15 out of 128, I think is fine. Nice. So it's about like 12% of the time. So if you guys do this experiment, you only have a 12% chance of ever getting 3 heads out of 10. Yeah? And that's it. That, guys, is the binomial distribution. It's basically tree diagrams, but without having to draw all of the trees. Yeah? So it's something dumb long, huh? Hey, yo, it's not that bad, Alex White. So let me put this phone on silent, man. Who's texting me? Me not interested. Okay. Let's practice again. The binomial distribution. You can model just think of the binomial distribution, guys, as quick tree diagrams. That is it. Yeah? You can model a random variable x with a binomial distribution, BNP. So this is how we write it down. If there's a fixed number of trials, n, there are 2 possible outcomes, success and failure. There is a fixed probability of success, p, and independence. And the way we write it down, guys, is like this. So we say x is distributed binomially with a fixed number of trials, n, and a probability of success, p. So in terms of the last example, when we were talking about the coin, we would say that this coin is modeled binomially with 10 trials, we're doing 10 flips, and the probability of getting a head is a half. So that's what it would look like for the previous example. And this is what the formula looks like. And we've just done this. We said to get a successful outcome, this NR is N choose R. Yes, another way of writing it. Then you have the probability of success. And then there's the probability of failure. Okay. Now in the last example, this was a half cubed. And this was a half to the power of 7. Yeah, because if the probability of success is a half, then 1 minus a half is also a half. Yeah. Anik, we'll get to the calculator in a second. When you get into the binomial distribution, you should never learn from the calculator first. But once you understand, then we'll do the calculator. After this question here, I'm going to be using the calculator. So guys, our calculator does all of this, but it's very important that you understand how it works. Okay, so let's take a look at this other distribution. X is binomially distributed 10, 0.3. Now remind me, guys, what does that 10 mean? What does this 10 represent? Let's make sure we understand what each... So the number of trials, good. So n, number of trials, yeah? What does that 0.3 represent? And yes, Taj. So probability of success. So guys, when you say probability, you must make sure you say of success. Very important, because probability could be success or failure. Yeah. So by using the binomial formula, find the following probabilities. Probability x equals 1. So what does that mean? So let's make sure we understand what this sentence even means. What probability is it asking us to find here? What does it mean x is 1? So it's important that we understand the English when we read this stuff. Probability of x equals 1. Number of trials also 1. So the number of trials is still 10. Good, Anik. So guys, it just means the 1 success. So you get 1 successful observation out of 10. So the equivalent of this in the previous example would be getting 1 head and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the previous example, this was actually the probability of x equals 3. I wanted to know 3 heads out of 10. I wanted 3 successful observations. This question is talking about 1 successful observation. Yeah? Now, if we're only looking for 1 successful observation, what would it be in terms of choose? So now we only want to talk about choosing. Yeah, we don't want to talk about the factorial. You could think of it in terms of factorial, but what would it be in terms of choose? Nice, Anik. Good luck with the mocks. Nice, guys. 10 choose 1. There's 10 trials, and I want 1 success. We're going to put that in a bracket. Times. What probability would we multiply it by? Keep in mind, when we wanted 3 heads, we multiplied by a half cubed. Now, remember guys, the probability of success has changed. The probability of success is now 0.3, and I only want 1 successful observation. Yes, Matty. Sainzy, no. I'll talk about the course at the end as well, but the summer 2024 is still running. But nice, Asha and Taj. So guys, you want 1 successful observation. The probability of success is 0.3. And you want 1 successful observation. Then we multiply it by the number of failures. What would it look like then? What would it look like then? So we want 1 success, and Taj, you're so close. It is power 9, but not 0.3. 0.7, good. So remember guys, it's failure. So 0.3 is success, 0.7 is failure. It will be power 9. Okay, good. We can type in this whole thing. So guys, in your calculator, we're going to do a bracket. We're going to do 10 choose 1 times 0.3 to the power of 1 times 0.7 to the power of 9. Okay, let's do that to 4dp. 1, 2, 1, 1. I think that's good enough. Okay, part B. This is a very important question, because if I say probability of x equals 0, what does that even mean, x equals 0? X equals 0. Good, Taj, 0 successes. No successes, nice guys. Now if I tell you no successes, what's another way of saying that in terms of failure? So you want 0 successes or something failures. 10 failures, nice. 100% failure, all failures. The way we think about x is 0, guys, is going to be very important, because when we do year 12 maths, it's going to get algebraic. I want you guys to think of this in terms of all failures. Now guys, there's only one way of having all failures. Look at this. You just have t, etc. What would that probability be? So Taj, yeah, you could do 10 choose 0. But actually, because it's all failures, there's actually only one combination for this. So what would the probability be if you just have the same thing over and over again? Thanks, Anik. I'm glad the explanation is clear. Nice, Gabriel and Zainab. So guys, it's all failure. The probability of failure is 0.7. And you want that 10 times. 0.7 to the power of 10. Now, if you were to do it in the old school way, you would say, okay, it would be 10 choose 0, because you want 0 successes. But then, you want 0 successes again. It would be 0.3 to the power of 0. But then you want all failures. It would have looked like this. But both of these values are 1, which is why we only write 0.7 to the power of 10. Yeah? But, you know, in year 12, guys, you get very used to this, this idea. But let's type that in the calculator. What's 0.7 to the power of 10? (0.0282). Sweet. In general, guys, with binomial, we will always do 4dp. All right. The next thing is probability that x is greater than or equal to 2. What does that even mean? What does it mean, probability of x being greater than or equal to 2? Two or more successes, Taj. Good. Now, the thing about this, guys, is that there's actually many options. You could have had, what, 2 tails. Wait, sorry, if we're talking about heads, sorry. You could have head, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. You could have had this. You could have had 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. Guys, there's so many different combinations. And there's no way you're writing the situation for every single one of these. So the way we do this is we're saying, look, I'm interested. Well, if we look at the number of trials, you could either get 0 successes, 1 success, 2 success, 3 success, 4 success, 5, 6, 7, 8, 9, 10. We could get any one of these. I'm only interested in this situation. 2 or more. I either want 2 successes, 3 successes, 4 successes, 5, all the way up to 10. But there's actually an easier way of doing this. Instead of adding up all of these probabilities, what could we potentially do instead? Can you guys see it? Look at the number line. Instead of doing x is 2 plus x is 3 plus x is 4 plus x is 5 all the way up to 10, what could we potentially do instead? And what you need to consider is what all probabilities add up to. What do all probabilities add up to? So not 10 factorial. First thing about what do all probabilities add up to? 1. All of these probabilities, guys, add up to 1. Everything I put in a black box adds up to 1. So if this is all 1, nice, Matthew, we do 1 minus these 2 probabilities. We minus these 2 options that we don't want. We just don't want there to be 0 and 1. So we're going to do 1 minus the probability of x equals 1, and we're going to subtract x is 0. We're going to subtract the options that we don't want, and then we're going to get the rest. And guys, we've already done that. We did that in part A and B. We're going to do 1 minus 0.1211, and we're going to subtract 0.0282, and that gives us our answer much quicker than doing 2 plus 3 plus 4 plus 5 plus 6, which is like what, 8 different probabilities you'd have to add up together. Here you can just use the answers that we already have. So 1 minus 0.1211 minus 0.0282. There we go. That's the probability of getting 2 heads or more. Lydia, what would you do if it was greater than 5? So our calculator does do all this stuff. So for much larger numbers, I'm going to show you guys how we do it in the calculator. Yeah. Right now, I'm just showing you the understanding bit. It's very important that you understand where things come from. But from now on, we're just going to use the calculator, and I'm going to show you how it's done. Yeah. So this, guys, is the binomial distribution. It's just helping us do tree diagrams without having to draw the trees. So check this out. Using the latest statistics from the intercity train service, the probability of a train arriving on time is estimated to be 0.8. During a week of commuting, I take the train on 5 different days. Using the binomial PD function, so this is in the calculator, it's going to do everything for us. What is the probability that my train arrives on time on all 5 days? So the first thing, guys, we need to understand is, why is this a binomial distribution? So first you have to, guys, tell me, why is this a binomial distribution? So to think about the conditions Fixed number of trials, yes, that's 5, isn't it? So it's what, 5 days. There's a fixed number of trials, n is 5. Okay, what else? The probability is the same each time. Set of trials, success or failure. What is the success and failure here? And the independence, exactly. So what do we mean by the success and failure? What is that in this example? Train arrives. Not just the train arrives, Zainab. Something a bit more specific about the train arriving. What does it say? On time. There you go. Nice. So either the train's on time or it's not. So it's important that when you guys read these questions, you are clear about what we mean by the success or failure. Yeah, in this case, it's on time or not. Okay, so at A levels, guys, we have to be very specific about things. We have to first define our distribution. So what we're going to do is we're going to let X, and we've been using X everywhere, haven't we? So this is our distribution. We're going to explain what it is. Let X equal the number of trains that arrive on time. That's what we're observing, right? And we're going to say out of 5 days. We must always do this. Then we're going to say X is binomially distributed. We're observing 5 days, and the probability of success is 0.8. Okay? Now, using the probability stuff, guys, like we did here, what are we trying to find out when you read part A? Probability of X what? What are we saying here? Before we do any of that, Taj, X equals not 1. That would be if it arrives on time on 1 day. Nice, Alex. So equals 5. Yeah, I want it to arrive on time on all 5 days. X equals 5. Okay? Now, guys, on your calculator, you should have the A-level calculator by now. If you don't, you're just going to have to look at what I have. So either you have the EX or the CW right now. You're going to press menu. Then can you see over here, number 7 has like this curve on it. That's the binomial distribution. That's a normal distribution, but we're going to be using that. You're going to press 7. Now it's going to give you some options. We want number 4, binomial PD. Yeah, binomial PD. So you're going to press number 4. You guys will have it eventually. Then we're going to press number 2 for variable. Okay, it's going to give us some options. It's saying, what is your X value? Your X value is 5. So we're going to press 5 equals N. You guys know what N is. N is the number of trials, 5. And your probability is 0.8 equals. There you go. There's your probability. So can you see your calculator does it for you? So if your school doesn't provide it, then you're going to have to get it yourself, Mike. 277. Okay, it's very simple. So guys, we don't actually need to write the choose stuff anymore. The calculator does it for us. Well, what part B? What probability are we trying to find in part B? And yes, Lily, that's the exact same as 0.8 to the power of 5. Zainab's going with X is 3. What do you guys think? Nice, guys. Exactly 3 days. So all that changes, guys, is I'm going to go on my calculator and I'm going to change X is 5 to X is 3. And there's my probability. Nice and simple, Mike. We don't need to write any choose stuff. Yeah, that's the underlying principle of what's going on, but we don't need to do that. Yeah. So that's it, Taj. That's why we need to be careful. It's not 0.8 to the power of 3, because it'll be 0.8 to the power of 3 times 0.2 squared times 5 choose 3. Yeah, like we were doing in the previous slide. Well, the last one. What is the probability that my train arrives on time on at least 1 day? What does that look like? On at least 1 day. It needs to arrive on time on at least 1 day. I'm not saying 1 day, I'm saying at least 1 day. Nice, Gabriel. And equal to, Lily, good. X is greater than or equal to 1. And Matthew, hold that thought. So we had a question very similar to this in the previous one, guys. It could either arrive on time on 0 days, 1 day, 2 day, 3 day, 4 day, 5 day. I want on time for all of these. What's a quicker and easier way of doing this? Better get off that talk Wi-Fi. Gabriel, x is 0. What do you have to do with x is 0? 1 minus Isaias. Good. So guys, like Matty said as well, is what we're going to do is we're going to realize, oh, my thing's bugging. Mate, hold on. You realize that 0 is the only one we don't want, so we're going to do 1 minus that. Now guys, probability that x is 0 should remind you of something. What do we mean by x is 0 again? Remember from the last slide? The trackpad is tweaking, mate. For real. What does x is 0 again mean? All failures, freaky, exactly. So guys, if success is 0.8 and there's 5 trials, what would be the probability of all failures? For all 5 trials, what would failures be? Asher, nice. So Isaiah, so that would be all successes. What would it be for all failures? Yeah, exactly, 0.2. Nice. You guys becoming professionals at this. So that's what we type in. 1 minus 0.2, whoops, to the power of 5. Boom. It's basically close to 100%. Yo, Sammy. Welcome back. What do you mean? Binomial, don't scare off my students, yeah? Binomial distribution is alright. This is good times, man. This is good times. Alright. So you can see, guys, how the calculator helps us a lot with all of this stuff. Yeah? Check out this question. In a trivia quiz, there are 25 questions. For each question, there is a 45% chance that a participant answers correctly, independent of all other questions. Find the probability that a participant gets a total of exactly 15 questions correct. So guys, using inspiration from the previous example, what do we need to do first? Let's see, Sammy. Let's see. So use inspiration from the previous slide, guys. What did we do first when we start a binomial distribution question? Nice, Zainab. We define x. We let x, nice guys, be the number of questions. You guys are experts already, mate. Number of questions correct, answered correct, however you want to say it, out of 25. So you should always say this out of. And then do you guys agree with Alex's x is binomially distributed? What do you guys think? Is x binomially distributed 25, 0.45? Or would any of you say something? Do you want to give a hand with some Australian first year engineering maths? Andrew. I mean, you can send me questions on Maths Does Neil on Instagram and I can see if it's relevant to my students. But otherwise, I'm not sure. Okay, you guys are right. There's 25 trials and the probability of getting something correct is 0.45. Now look at part A, guys. What probability are we even trying to find here? X is what? Freak, are you saying equal to? Or, so yeah, guys, you just be specific, like Uma and Zainab are doing, because it could be greater than, it could be less than. We should just say 15, equal to 15. And now let's go into our calculator. If you have it, you're going to go menu, then number 7. Then we need binomial PD, variable number 2. X in this case is 15. The number of trials was 25. The probability is 0.45. And there we go, there's our answer. So this stops us from having to do 25 branches of a tree diagram. We can just do this straight away. Nice. All right, part B. If 200 participants join the competition, find the expected number of participants who get exactly 15 questions correct. So right now we know that the probability of any one person getting 15 questions correct is this. What do we do with this when we're now talking about 200 participants? Exactly, Taj and Freaky. We just times it by 200. All this says that 5.2% of the time you will get 15 questions correct. So we just need to work out what 5.2% is of 200. We just multiply them together. Yeah, same as how it was at GCSE. Alright, so we obviously have to round this because you can't get... you can use the answer button as well, yeah. It's about 10 people. Obviously not 10.4. So you're going to say about 10 people. Hey, yo, this people, mate. This people. And that's it. Pretty simple, right? Obviously the binomial distribution can get harder, but this is, as long as you understand this underlying principle, it's really easy. Hey, yo, kiddies, man, you got this, bruv. Okay, so guys, that is the binomial distribution. Yes, Lily, if it was 10.6, you would round up. It's just the best approximation, yeah? So guys, just a quick information again about the course that starts. For you guys, you're on a Tuesday, so it'll be on the 10th. So you guys start on the 10th. Remember, this is the last summer school, unfortunately. Like if you cry every time. So... let me just remind you about the course, then we'll play Kahoot in it. So, the course that starts on the 10th for year 12s, 80 hours of lessons, 80 homeworks over the course of the year, and monthly assessments to make sure you guys are staying on track. So if you have the pro course, guys, you get access to the mentor. So in the stream, guys, you've got Yo-Yo. You can see her chatting away. Yo-Yo is one of the mentors. The beautiful thing about the mentor, guys, is you can literally message Yo-Yo as much as you want with any questions you have that is maths related, whether it's maths in school or the maths you're doing with me. Yeah, unlimited support there. But if you're on standard, you don't get access to the mentor, but you get everything else. You get the lessons, obviously, award-winning platform. Yo-Yo is one of the OG mentors. She's been here basically from the beginning, guys. So. Yeah, then you get access to recorded lessons whenever you want, professionally made workbook and materials, and access to a vibrant student community. All right, so as we've said before, guys, if you're going the one-to-one tuition route, you could be paying anything between £25 an hour to £200 an hour, depending on what quality of teacher you're looking for. Here's an example, guys. We always go back to my man Tom, who charges £185 an hour, which fair play. But, you know, let's be realistic here. You know, the average market for high quality tutors, you're paying at least £60 an hour, yeah? Now, over the course of the year, guys, for year 12, you'd be paying about £5,000, yeah? And that's just for, you know, the hour of tutoring, and then that's it. Yeah, you interact with them for an hour, and then you don't get anything else outside. And on top of that, you have to select the tutor, you have to schedule the lessons, you have to manage your timetables. They don't have many reviews to gauge effectiveness. Like here, guys, you can see 6 reviews, 3 reviews. The guy behind me has 6 reviews, 8, 3. You know, some of them have a few, but in general, few reviews, you can't really gauge effectiveness, and no free content to assess teaching style. You guys see me on TikTok, Instagram, even now, you guys all see the way I am as a teacher, right? Lack of resources, no recorded sessions or extra study materials, limited review of past lessons, and inadequate preparation. So usually one-to-one tuitions just read out of the textbook, which is why we're doing what we're doing here. Let's improve the value. Assuming that you settle for an intermediate tutor, guys, you'd be paying, like we said, about £5,000 for the year. If someone was charging £60 an hour, it would be way more if it was a more expensive tutor. Or us, which is just £700 or £900 if you wanted a mentor for the whole year. So remember, you're talking about £5,000 versus what we're charging, 5 times cheaper. But obviously, because you guys are on the summer course, we're doing it extra cheap. We're going to give you more than 30% off. We're going to take off a third of that value. So this is all you pay for the whole year. And obviously you can break it up into installments as well. If you don't want to pay this full thing for the year, that's fine. We break it up to help you guys out for any subject tag, yeah. But we also have a package if you guys want multiple, yeah. All you guys need to remember is this code word though, yeah, summer 2024. Just remember that, and then we will plug you with this, yeah. Remember this for the whole year, yeah. Summer 2024. Also, you have 14-day money-back guarantee once the course starts. So if you pay today, for example, you have until 2 weeks after the 10th of September to change your mind. Yeah, so it's nearly a month you have to change your mind at the moment, yeah? And there'll be no questions asked, guys. You would get a full refund if you decided you didn't want it, yeah? And why stop at maths? Like we said, guys, you've got Laura, Brooke and LaJoy for biology, physics and chemistry. Just so you're aware, for year 12, guys, you have the mega genius Dario taking that, but then when you get back to year 13, you'll be back with me, yeah? So Dario, who is a first-class physics imperialist, 6 years of teaching, head of Key Stage 4, and he has a PhD in physics from Warwick. He's a proper legend. Bro is an absolute genius. He's going to be helping me out with year 12. But when you guys get back to, I think you guys were taught by Dario already during like cram course, what was it, Easter revision, I think. Was Dario in Easter revision? Monkey, as long as there's enough time during the lesson, for sure Dario would do cahoots with you guys. It was chemistry. Guys, Dario is just built different. Bro is just he's just so smart, it's wild. So guys, you can get all the subjects. So it depends on what you're doing, right? So if you're doing maths and all the sciences, like we would like sort you out for that. That's known as the ultimate pass. It's up to you if you guys want the ultimate pass. And this is how much it costs for the ultimate pass. It works out to 2 to 4 per hour. So one lesson for one subject, guys, it looks like this. But for all of the subjects, it looks like this. Yeah? Man bun nil. Rah. What a time that was, man. Can't believe it. Nice based. Smashed it. Nice one, nice one. So yeah, that's that. And like I said, we can break it up into 4 installments. This is how much it would look for the ultimate pass. So guys, if you wanted all the subjects, this is how it would look for standard and pro. And remember, for all subjects, guys, you would get a mentor for maths, you'd get a mentor for biology, chemistry, physics. You'd get a mentor for all of these, yeah? If these grade boundaries weren't ridiculous, yeah, for real, they were pretty high this year. But this is a limited time offer, guys. I don't know exactly the timeline, but it's definitely going to finish this week. Is the ultimate pass for every subject? Yes, Gabriel. So for all of physics, chemistry, biology, and maths. But if you just message my team, I think it's for 3 subjects actually, because everyone takes 3 subjects. So sorry, this is for 3 subjects, yeah? Cool. Limited time offer. Guys, remember summer 2024. This is in the description as well. So guys, if you look at the YouTube description, you have a link to, it says exclusive main course discount. If you click that, it will just write summer 2024 straight away. And then you guys can just ask my team for more information. Yeah. And just one request from me, guys. We've just spent the whole time doing summer school. I know some of you in the chat have already done this for me before, so you don't have to do it again. But I'd really appreciate if you could do a Trustpilot review. You just click this link in the description before we do Kahoot. Once I get Kahoot up, it does help me out a lot. If you could hit me up and plug me with the 5 stars. I know a lot of you guys have done it already. Ayo Gabriel, you don't need to do it again. Yeah, guys, only if you've not done it before, it really helps me out. And love for that. And love for those of you who have done it already. If you've done it already, guys, don't worry. Nice, Kira. Thank you. Nice one, Matty. Thank you so much. Let me get this Kahoot up so I can smoke you guys one last time. Because I won't end up teaching you all for a while until you get to year 12. I mean, until you get to year 13. Because then it's going to be Dario taking over. But all these streams we've done over summer, you guys have access to as well. But Dario's going to re-go over it. Alright, so coming in the chat. So yo, on TikTok. If you're on TikTok, sorry, I can't see the chat right now. But if you want to come join Kahoot, come to YouTube, Rev. Where was I? Sorry. There we go. So if you're on TikTok, come to YouTube if you want to play Kahoot. And I will see you all later on. By the way, I'm staying on YouTube, but I'm just ending the TikTok. So I'll see you guys in a sec if you're coming over to YouTube. Love for the reviews, guys. Thank you, thank you. Yeah, I'm going to spend year 12 prepping just to beat you in Kahoot all year 13. So one thing you guys have to understand is that when you get to year 13, we don't end up playing Kahoot because we don't have time. But that's something that you guys need to be aware of, yeah, before you guys shout at me, innit? Hey, you allow me, innit? When you get to year 13 is too serious, guys. I wish I could do Kahoot with you. But with you guys going into year 12, you'll be alright. Oh, no, but there's summer school. There'll be summer school next year, Lily. Don't worry. It's not the last Kahoot you'll play with me. Don't worry. And also, I think, Yo-Yo, do you guys still do Kahoot with the students? So the mentors also hold Kahoots. I can't remember. Lily, do you guys, Yo-Yo, do you guys still do that? Or did that even ever happen? I can't remember. So guys, you got 30 seconds sometimes. So maybe we can do it a bit more regularly and then I can join those as well. So we'll see, we'll see. It's not the end yet. This is the end. My only friends. I've got memory loss. Hey, you're violent. Watch me destroy you guys. Oh wait, do you guys need calculator? Guys, you need your calculators, yeah? Alright, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. When mentors hold a session during weekends, timeout. So, okay, there we go. Ashwin, I don't have an exact timeline for you there, but it's the spots are limited. My team haven't told me, I haven't asked, but definitely within the next couple of days. So if I were you, I'd just get in a conversation with my team at least. All right, so where am I going? Wait, what is this? X is less than 9. Hey, yo, Dom's violating with this one. We need binomial CD. So guys, you need binomial CD on your calculators for this one. You guys are learning on the job now. Wait, hold on. 7. Oh, I just got. I'm in 5th place. Okay, so we didn't look at this properly. We didn't look at this properly today, but I'll show you guys here. If you go onto your job, we were using binomial PD. Yeah, that was number 4. When you press down, you've got binomial CD, which is number 1. Then you go to variable and you just press 8. Less than 9 means 8 or less. So when you do that, you get 0.7623. But whose name is Neil? I miss you. Wait, who's that? Are they even on? Okay. I'm somehow on the leaderboard with 1,000 points. Okay. Let's see. Next one. You guys can make the comeback. Hey, yo, what? Oh, it's calculator. Oh, wait, hold on. Oh, I'm in the wrong setting. Oh, oh no, I need to find it. It's pretty slow. Yo, Andrew, what's my background? Do you mean like my tertiary education in university, degree of maths from UCL? Londres. Samurai, got a D first sit, resat, and got an A. Yo, a few marks of an A star, but remark wasn't enough. Hey, yo, Samurai, dude. Still though, an A is amazing. Well done, man. Going from a D to an A is wild. You're welcome. So with this one, here you just type in the calculator and you just get 37 root 3. Alright. Hey, yo, who is Neil? I miss you though. I'm not even gone. I'm still here, bruv. But AP is doing... Who's AP? Next one. We can model a random variable x with the binomial distribution of the infinite number of trials, true or false? Oh, you guys should all know that. Hey, yo, monkey, why lying? Oh, hey, yo, who said true, man? Guys, fixed number of trials. Guys, come on, man. Fixed number of trials. Can't have an infinite number of trials. AP is on a mad one right now. Hey, yo, man bun Neil. Hey, yo, what are these names? Alright, next one. Have you ever seen how lots of people are sending back their AQA papers again? Are they? I didn't know that. What, did AQA mess it up? Oh, what's that? Oh, I didn't know AQA messed it up that much. Lily, you're AP. Okay, so 2 went for Australia. They got played. That's definitely New Zealand. Because the red stars. Oh, you're man bun. Man bun Neil. Oh, the leaderboard has not changed at all. The thing is, can either anyone beat AP? AP would have to get it wrong. I could potentially beat AP. Neil, I miss you, and Man Bun Neil could as well. Have any of you guys seen that Turkish guy on Instagram who's like, I miss you? He's so funny. He has like the moustache. He's too funny, man. Aussie flag. Oh wait, hold on, you're distracting me. Oh! Wait. Binomial PD. Okay. I don't know. Can I be AP? We'll see. Nice, Andrew. Where's the love of maths come from? Sorry, I missed that, Andrew. I don't know. I've just like always been a maths geek, to be honest. I'm on the podium, but I don't know if I've won this. So I type this stuff in the calculator. So in my opinion, Andrew, what you do is you figure out what you're good at, and you just go with that. So what you're good at, in general, you're most likely, on average, you'll most likely enjoy it. So, especially when it comes to education. So, what are we saying? Don't have calc, I'm cooked. So Neil's man bun, it's not looking good, bruv. Matty, you scraped the podium. Oh no, I think AP did it. Who's AP? Yo, how? They absolutely smoked it. Who could be AP? I don't see any APs in there. I'm not sure who AP is. That's a W, but AP. AP cooked me. Hey, it's not looking good, man. It's not looking good. If it wasn't for that first question, I was winning, bro. That first question was a bit of a curveball. Alright guys, well done. Like I said, if you guys could do that Trustpilot review for me, it would help me out so much. Thank you guys a lot. Hopefully the summer school was useful to you. And if you do want to join the main course, in the description, you do have the link that will take you straight to a chat with my team. I can put in the chat as well. If you just click this link, it will take you straight to WhatsApp with the summer code in there. You can have a conversation with them as well. It's no strings attached at the moment. You can just chat to them and ask them about more details about the course. But yes, guys, well done. Been a pleasure teaching you. And for sure, I'll see you all in year 13 when I'll teach you, but also we'll see you guys on the year 12 course, hopefully. All right, guys, have a nice rest of your week, and I'll see you all later. Peace out, guys. Nice one. See ya, hunks. Nice one, guys. See ya.